we have discussed what a quadratic equation is. We said a quadratic equation can be defined as a polynomial with the highest degree of 2. And we did say that it is of the form what? It is of the form ax squared plus what? Plus bx plus c equals to 0, such that a must not be equals to 0. And I explained the implication of a being 0. When a becomes 0, this equation ceases to be a quadratic equation. It automatically becomes a what? It automatically becomes a linear equation, actually. But there's a need for us to study the the graph of a quadratic equation, because I did say that there are 4 basic methods to solve quadratic equation, one of which is the graphical method. But when we are plotting our graphs, what are the things to expect? How do I expect my graph to look like when I plot them? Now, the major determinant of how our graph is going to look like is the coefficient of our what? X squared, which is our A. Actually, albeit, whenever we solve or plot a quadratic equation, we are going to be having 2 answers. Now, the nature of these 2 answers depends on the equation we are given. Albeit, the root of this equation can be 1, can be unique root, 2, uniform root, and number 3, imaginary root. I will tell you when all of this comes out using a graphical illustration as the case may be. So imagine. Now notice, when my A is greater than 0, meaning when the coefficient of my x squared is greater than 0, then I will have 3 major kind of graphs. The first of which looks like this. Number 1 is that my graph will face up. Please note, whenever my A is greater than 0, whenever you plot your graph will always face up. Your y-axis, your x-axis, and your origin. Now, the point at which the curve cuts the x-axis is where we derive our what? Or the roots of the quadratic equation, what that we can call x1 and x2. That are actually numbers, but just arbitrary. So x1 and x2. But in this case, this is what we call unique root. We call it unique root. Why is it called unique root? Because root x1 is not equal to x2. They are different points. What does that mean? When you solve quadratic equation and you have -2 or 3, -4 or 5, -1 or 1, when you have 2 different answers, it's called unique root. But when I plot this graph and my graph still faces up, but only touches the turning point, touch the x-axis at the point and moves up, albeit is still greater than 0, when my A is still greater than 0, then I'll be having 2 roots here, but my root is going to be x1 equals to x2, y-axis, x-axis, origin. The point at which my x1 equals to x2 is called uniform root. Uniform root because what? Because the roots are the same. X equals to 2 and x equals to 2. X equals to 4 and x equals to 4. The answers are the same, so we call them uniform roots. And whenever you plot the graphs of such equation will always look this. Then the next one is when you plot your graph and it's of this form. It faces up, but it never gets to touch the x-axis. Then it's going to have an imaginary what? Imaginary root. Let's try. Imaginary root. Now this is called imaginary root because it is not having its answer on the weak plane, it is having it from the complex plane. I think that's the top and another name. Then, what of the case when my A is less than 0? At each cases, or in each cases, whenever my A, which is the coefficient of s squared is less than 0, my graph will always face down. So I'll have something like this, x-axis, then my y-axis, the origin, my graph is facing down. But this time is cutting my x-axis twice, x1, x2, So it has what we call unique roots. Unique roots because my x1 is not equal to what? X2. And at this point, where my graph is also is facing down, but is of this form, then here is x1 equals to x2, y and x. This is also called uniform roots. Uniform roots because what? Because the two answers are the same, actually. And the imaginary form is like this, where I have my curve to be angling, not cutting the x-axis at all. Then it's called imaginary root. Yes, imaginary what? Root. That's the case that we have when it comes to cutting graph. In other words, whenever you are cutting a quadratic graph, you expect this kind of shape depending on the value of your a, which happens to be the coefficient of your x squared. Actually, so that is how we know where and where our graph is to face. Okay, the next important thing I believe that we must know is how to plot a quadratic graph. Yes, I'm not able to plot a graph here because I don't have a graph that I can explain it to you. But I will explain to you, and if you listen very well, you will have to plot this graph the way it's going to be. But basically, one of the major ingredients, so to speak, that must be considered in plotting a good graph are these things. Yes, number one is when you are plotting a graph, know that a graph must have a scale. A scale is our unit of measurement. Then, number two, a graph must have a title. Yes, without a title, I'm plotting a quadratic graph, and I titled it. Next is it must have a table of value. And I'm going to be focused on this table of value. I'm going to at least take one example to explain how to plot the quadratic table. Then a graph must be neat, actually. Must be neat, not rough. You must do all your best to ensure that you have a perfect curve as a trend. Then the next one is that it must have the x and y axis indication. It must indicate the x and y axis by arrows. You must indicate it there. And it must have an origin, a starting point. We should be able to do that because starting from basically. So having all of these guys and maybe a few more makes us have a very good graph plotting. So for instance, you are asked to plot a graph of say number one, plot a graph of say y equals to x squared minus, let me say 2x plus 3. And you're asked to plot a graph of say y equals 2x squared plus lx minus 4. Let's see how I can plot this graph. Let me have one more to hit. You're asked to plot a graph of 1 equals to 1 minus 2x minus say x squared. No, let me put 3x squared. How do you do it? I'm going to do number one. I'll do that for the board, and I hope you're going to be fixing part 2 and 3 by yourself. All you need to do is to follow the example I'm going to be doing on the board. Exactly. So what do I do? Go to control the simple table, and on this form, I hope my hand is straight enough. A simple table. Then from there, you will be given an x range. So most of the times, these x ranges are given in inequality form, and sometimes you are given the liberty of choosing any x range you like to choose. So, but I'm going to be, for the sake of simplicity, I'm going to be taking my ranges from -3 all the way down to 2, -2, -1, 0, 1, then 2. Having said that, the next thing here is x squared. So I use x squared, put my x squared here, then put a demarcation as well, then followed by -2x minus 2x, a demarcation as well. Then I have -4 minus 4, a demarcation as well. Then the last part of it, which is what? Which is y. That is the whole of my equation. Yes, the whole of my equation, which is simply y equals x squared minus 2x minus 4. Eventually, then I'm going to be having. So, having said that, All these values are my x squared, are all variables. So it means x is minus 3 here. When I square it, I'm going to be having 9. You get it? But note, minus 3 squared is not the same thing as minus 3 squared. Minus 3 squared here will give you minus 9, and minus 3 squared here will give you 9. And I need to let you know why this is this form. I'm talking about minus 3 as a number, the whole of it squared is out of 9. Same with minus 2 squared, that will give us 4. I same people write minus 9, which will give you a total error eventually. Here will give you 1, give you 0, here will give you 1, and here will give you what? 4. Then minus 2 times x, meaning minus 2 times minus 3 will give you 6. Minus 2 times minus 2 will give you 4. Minus 2 times minus 1 will give you 2. Minus 2 times 0 will give you 0. Minus 2 times 1 will give you minus 2. Minus 2 times 2 will give you minus 4. Then minus 4 is a constant. I'm going to try this all through. Constant is entity that is not prone to changes. It's going to be all the same. And score does not change, so it's a constant. Then I'm going to be adding it up. 9 plus 6 is 15, plus minus 4 is 11. 4 plus 4 is 8, minus 4 is 4. 1 plus 2 is 3, minus 4 is minus 1. 0 plus 0 is 0, minus 4 is minus 4. Then 1 minus 2 is minus 1, and minus 4 is minus 5. Then 4 minus 4 is 0, then minus 4 is 3 minus 4. With these, I have my table value ready to be plotted. If you follow the same example I've given on this board, you can easily solve 2 and 3. And this is the life of quadratic equation. If your table is wrong, you can't have a perfect graph. So your table has to be perfect for the graph to make a lot of sense. So thank you so much for being